Good morning, everyone. So, for today's update, I have completed two major questions of linked list, and with this, I have reached to the half of my journey on linked list. So, the first question is adding up one number to our linked list. So, in this question, basically, we have given a linked list, for example, 159, and we have to add a one number, that's 159 plus 1, that's 160 is the answer. So for this, for the brute force, I have taken the approach where and I have reversed the linked list and simply add the one number as a sum to my 9, and after, if there is a carry, we for take that carry with the next node and simply add with that, and if there is no carry, we just break down and return the answer itself. So that's how I do the brute force. But as it is the brute force, so for the optimization, I have used the recursion, and in recursion, we have used the concept of backtracking. So in the backtracking, firstly, we make a function from which we traverse all over the linked list up to the end of the linked list, and there we make a backtracking function where that's the helper function, and in that function we calculate the carry. If it is going to be null, then like we have a node 159, we will take that example, and we will traversing from 1, 5 and 9. So our base case will be the null condition. When our temp reaches to the null, we got the base condition and we revert back through carry option, and if carry is less than 10, so we will just return the carry 0, as there will be no carry, and return back easily and backtrack the question. And if there is greater than 10, so we will return the node as 0 and carry as 1. So that's how we backtrack over the nodes and eventually add all the numbers using backtracking concept. So that's how I've solved that question. And other than this, I have also solved second question. That's the find the intersection point in a linked list. So in this question, we have two linked lists, and both are intersecting at some point, or maybe not intersecting at any point. We have to check that point. If there is a point exists, so we have to return that point where they got intersect. So for the brute force, I have used the concept of map, where I have put in a fully single one linked list into the map, and in the map I have stored there it, all over the node, not the number only. We have stored the node and map it with the value of 1 as the carry. So in this question, after storing all the nodes of one linked list, we eventually check the second linked list. If there is a node that matches to our second linked list, so we eventually return that node, and that's the intersection point. So that's how I solve the intersection point. But there will be a better approach, and better approach says that suppose we have two linked lists and we have to find the intersection point. So in the intersection point, firstly we will calculate both linked list length, and whichever will be the longer linked list, we will move that d steps ahead. There d will be the difference between the length of both the linked list, and after getting the difference ahead, we will move our larger linked list, and eventually we will meet at the same zone. And after this, we can move both the linked list with one step, and eventually they will meet at some point, and we will return that point simply. So that's the better approach, not the best and optimized approach. So for this, the complexity will be big O of n1 plus 2n2, as we are calculating the n1 all over it, and then we are again calculating the length for n2 itself, and after that we are going to search the element uh, by moving one round again. So that's how that question had solved. For the optimization, I've used the new but a simple theory. So in this theory, uh, we will simply move both the linked list temp by one, and eventually uh, whichever linked list node reaches to the null first. So we just switch their next pointer to the head of the second linked list, and that's for vice versa. So while traversing, if any of the temp reaches to the null pointer, then the head of the another linked list, we will put our next node to the head of the another linked list, and that will be for both the linked list. So there is a proof of concept for this solution, and that's how I solved this problem. Because of this, the complexity reduces to n1 plus n2. So that's how I solved both the questions, and I have solved them over LeetCode also. Mm, and they have returned well solution. Hope we will do further good questions and add our this linked list concept on the target that we have fixed. With this hope, this video ends. Thank you.